Okay, so now I'm going to tie the entire chapter, or actually the last part after the variations, tie the synthetic division, long division, solving for our equations. We're going to try to tie it all into the calculator here. So the first one doesn't really have a lot to do with the calculator, but then we'll move toward the calculator after that. So if you don't have your calculator, you can go ahead and grab it, and then we'll use it later. So it says write the cubic function. So question number 1, write the cubic function that has x-intercepts at -4, 1, and 3 and passes through point 0, -6. Okay, so how are we going to do that? Well, if you remember back to our quadratic, we said y equals some kind of constant. We don't know what that constant's going to be, or some kind of value that's going to stretch or shrink our parabola. In this case, it's going to be a cubic because we have 3 roots. So it's x minus root 1 times x minus root 2 times x minus root 3. Okay, well we have our roots. Our roots are -4, 1, and 3. So y equals a times x plus 4, x minus 1, x minus 3. So basically we have to find the stretch factor here, right? In order to solve for this, we have to find the stretch factor. Well, how can we do that? Well, what other information was given to us? Well, it was given that it passes through point 0, -6. What does that mean? That means when x is 0, y is -6. So if I plug in for my x's and I plug in for my y, then I can solve for a, and then I plug that back in. So when y is -6, x is 0. So we have 0 plus 4, 0 minus 1, 0 minus 3. So -6 equals, so this is 4 times -1 is -4, -4 times -3 is positive 12. I divide each side by 12, so a equals -1/2. So my final solution, or the equation, the cubic function, is -1/2 times x plus 4 times x minus 1 times x minus 3. Looks a little funny there. So x minus 1, x minus 3. And that is my equation. Do you have to multiply this out? Absolutely not. It just takes time, so no need to do anything else. You can leave it in this factored form, and you are done. Okay, number 2, this is our first calculator problem. It says use your calculator to approximate to the nearest tenth the zeros for this function. So you grab your calculator, you plug in x cubed minus 9x plus 9, you graph it, and this is what you should see, right? So I see this right here. You can make your graph bigger or smaller, adjust it if you want. Okay? So then what does the question ask us to do? It says approximate the zeros to the nearest tenth of this function. So go back over here to your calculator. So how are we going to approximate our zeros? We're going to go to our menu, and we're going to go to Analyze Graph, and we're going to calculate our zeros. Remember, your lower bound is going to be to the left of the 0, upper bound to the right of the 0. So right here is one of my zeros. -3.41, 0. So that's 1. Okay, where's another one? So go back, go to your menu, Analyze Graph, 0. Here's the left of the 0, here's the right of the 0. Here's another 0. What do we get? We get 1.18, 0. Okay, my third one, do the same thing, menu, Analyze Graph, 0. Go to the left of the 0, go to the right of the 0. Here's my third one, 2.230. And so here are my 3 zeros, right? It says to the nearest tenth. Okay, so I didn't round to the nearest tenth. My short-term memory is not very good, so I have -3.40, 1.20, and 2.20. So there are my 3 zeros. So that's how you do it. So simple. You use your calculator. If there's no rational roots, then this is what you're going to do. Right? This is for no rational roots. So let's look at our next one. Okay, what if there are rational roots, but what if there's such a big long list? You don't want to sit there and guess and check with synthetic division all day. So we might put one like this on the calculator portion of a test, but you have to show work in order to get it down to a compressed or depressed polynomial of a quadratic to finally get all four of your solutions. Right? So you start with, or in this case, sorry, we're going to have three solutions. So we start with 4x to the third power. Minus 9x squared plus 7x plus 12 equals 0. And we're trying to eventually solve. So we need to find all three answers. Okay, so let's first list the possible rational roots. Well, my h possibilities are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 12. You can see why this is going to get a little bit yucky as far as you guessing and checking with synthetic division. Your k's are plus or minus 1, plus or minus 2, and plus and minus 4. When we combine those, h over k, so it's plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 4. Okay, exhausted the ones. But look how many more times we have to do this. Plus or minus 2 over 1, plus or minus 2 over 2, we already have that. Plus or minus 2 over 4, we already have that. Okay, 2's are exhausted. Plus or minus 3 over 1. That's new. Plus or minus 3 over 2, plus or minus 3 over 4. Okay, let me erase this. Then we move on. We've exhausted the 3's. How about 4? Plus or minus 4 over 1. Plus or minus 4 over 2, that's 2. Plus or minus 4 over 4, that's 1. Those have been exhausted. 6 over 1. Plus or minus 6 over 1. Plus or minus 6 over 2 is 3, already listed. 6 over 4 is 3 halves, already listed. Okay, then we have plus or minus 12 over 1. Plus or minus 12 over 2 is 6. 12 over 4 is 3. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 possibilities. If you don't have a calculator, how in the world do you know where to begin? You don't. You would just hopefully be lucky or not so lucky and spend lots of time. Okay, what might help you eliminate some of these 20 is using Descartes' rule of signs. Well, let's see if that actually does help. So we're going to take the positive, right? We're going to do f of the positive numbers. So 4x to the third stays positive, then we have negative, positive, positive. How many sign changes do we have? We have 2 sign changes. So that's 2 possible positives or 0 possible positive real roots. If we put a negative x in, well, my first term changes to negative, my second term stays the same, my third term changes to negative, my fourth term stays the same, so I only have 1 sign change. So this one is 0 imaginary, this is 1 sign change, this is 2 imaginary. So it didn't really help me. Either 2 of these possible 20 roots are positive and 1's negative, and those are my 3 rational roots, or my 3 roots, or 1 of the negative ones works and the other 2 are imaginary. So you can guess it's probably going to be this row right here. That's why we're making you show work. But how can your calculator help? Well, your calculator is going to help by graphing it and actually looking on your graph to see what one of the roots is. So go ahead and grab your calculator and plug this in to your calculator. I'm going to do that too, but I'm going to pause so I can go a little faster. Okay, so hopefully you graph this on your calculator and it looks something like mine, and you can see that there is only 1 rational root down here and the other 2 are imaginary. So now we have to figure out what that rational root is. Well, it's negative, so I'm going to go over here, analyze graph, find my 0, my lower bound to the left, upper bound to the right, and there I can see it's negative 3/4. Okay, so how does that help me? So one of my roots is negative 3/4. Well, now that I know that, I can do synthetic division. Right, so here's my synthetic division. I know this is one of the solutions, one of the x-intercepts, one of the roots. So I am going to divide to get my depressed polynomial so that a cubic can change into a quadratic, and then we can use the quadratic formula to solve. So we add straight down, then we multiply, then we add straight down, then we multiply, add straight down, multiply. But don't forget, these coefficients, notice they're kind of big, they're all divisible by 4. So our next step is we need to divide each of them by 4. So our new coefficients are 1, -3, and 4. So what does that mean? That means our depressed quadratic is x squared minus 3x plus 4 equals 0. Use the quadratic formula to find your final two imaginary solutions. So sure enough, there were 0 positive real roots, there was 1 negative real root, which means my final two roots must be imaginary numbers. So do the quadratic formula and solve. You can pause and do this on your own, or you can just follow me. So negative b, okay, so here we finish it up. It's 3 plus or minus the square root of -7 divided by 2. So we take out the negative. So it's 3/2 plus or minus I root 7 are two of the roots. They're both imaginary. And my third root is -3/4. So that is one of the ways you will use your calculator from now on to help. But expect to have that only when you have this big long list and it's really difficult to try to decide where to begin. Otherwise, do expect on a test to have a problem where you do not get to use your calculator and you still have to go through the same process. It's just that your possible rational roots will be far fewer, making the whole process a little bit more manageable. Okay, moving on with more calculator stuff. So now we just want to try to get you familiar with your calculator, how to graph it, what happens under certain conditions. So I'm going to go ahead and stop now and start a new video so you can see this information in a different video. Actually, maybe I'll do this first example and then you will do the bottom part on the video by itself. So we're going to sketch this function, so go ahead and graph it into your calculator. I'm going to pause and do that with my own as well. Okay, so this is what it should look like on your calculator, right? We have a 0 here at -3 and a 0 here at 2. And how do I know it's a 0 at -3 and 2? Well, that's easy because I look at this, right? This means one of my zeros must be -3 and one of my zeros must be 2. Now, the next thing we're going to do is we're going to look at the turning points. It says turning points correspond to the local maximum or the local minimum values. So why is it turning points? Well, it's where the graph is turning from increasing, so it increases, and then suddenly it changes direction and starts to decrease. So that's pretty significant, right? So that's a turning point. It changes from an increasing graph to a decreasing graph. Then as you follow along the graph, it changes from a decreasing to an increasing value. So your y value is decreasing, 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 then suddenly it starts to increase again. So those are turning points. We call those maximums and minimums. Notice it says the word local, because this is not the overall maximum, because you can see this graph goes infinitely upward. So there is no maximum, because it never stops increasing. But right here in this area, that is a local maximum, because it's a place where it turns from an increasing function to a decreasing function. So how do you calculate it? Well, we need to calculate our maximum minimums. That's easy. You just go to your menu, you go to Analyze Graph, and you can see right here 2 and 3 have your maximums and minimums. If I go to my number 2, it's a minimum I just chose, so this is clearly a minimum. Minimum occurs when you go from a decreasing to an increasing, right? That's a minimum right there. And you can see that minimum occurred at the 0 to 0. So this specifically is a minimum. Okay, sorry, so we should be putting these points over here. So this is a minimum, so we know it's going to come down like that, go up infinitely. But let's go back and calculate our maximum so we can put that on our graph. So you go to Menu, Analyze Graph, Maximum, go to the left, go to the right. Here's my maximum. It's -1.33, 3.09. -1.33, 3.09. That is a maximum. So I'm going to finish up here by graphing it, and then I'll see you in the next video. So -1.33, 309. So it's going to be something like that. So it comes down, reaches its maximum, that's its minimum, continuously goes negative forever, continuously goes positive, the y values go positive, and that's our graph. Okay, I will talk to you again soon for the remainder of the worksheet. Bye.